Okay, in the last video, we talked about the mole, how many atoms it is, and then we also talked about molar mass, which is the masses listed on the periodic table per mole of atoms. My example at the beginning to show that we use this type of calculation in everyday life was that I made my wife very angry and I bought her 3 dozen roses. So we could easily figure out that 3 dozen roses is equal to a specific amount of roses due to knowing how many roses are in a dozen. So we would know that 12 roses are in 1 dozen. So if we take 3 times 12, we will find that I got 36 roses for Mrs. Fain. She's very, very happy. Out of the doghouse once again. However, what if we don't have a nice round number? What if I called the florist and I was like, I want 2.43 dozen roses. Can we still solve this? Of course we can. We still know how many roses are in a dozen, which is 12. And we know that there's 12 roses for every 1 dozen. So we just have to do the same math. It's just not going to give us as pretty of a number. So we're going to take 2.43 and multiply by 12, which gives us 29.16 roses. Now, obviously, we can't have 0.16 roses, so it would be 29 roses. But if we were going to use significant figures here, we would actually get 29.1 roses because this number here has 3 significant figures. Or actually 29.2 roses, I guess. So we would need to round this number to 3 significant figures. So 1, 2, and 3. So 29. That 6 is going to make that 1 a 2. 2 roses. Now, why didn't I use the 12 in my calculation for significant figures? And the reason I didn't is because that is a defined number. There is 12 in a dozen. That is the definition. So, since 12 is in 1 dozen, that means that number is 100% accurate and we don't have to take it into consideration of our significant figures. Now, when we're dealing with mass and number of atoms, we are going to have multiple different variables that all have different numbers of significant figures, so we'll have to take into consideration our numbers there when deciding our final answer. So we're going to look at grams per mole and how many moles we have of different things in the rest of today's video. So we looked at sodium chloride yesterday. Now, let's say, so when we're looking at this, we've got 58.4427 grams per every mole. So that is and that's without any rounding for significant figures at this point. So let's look at what would happen if we had 2 moles of sodium chloride. So if we had 2 moles of sodium chloride, and we're going to say that we have 2.00 moles, just so we can have more significant figures of sodium chloride. we know that every 1 mole of sodium chloride has a mass of 58.4427 grams. So how many, what was that, 58.4427? How many grams of sodium chloride do we have if we have 2 moles? So just like we did up here, in this example, we're going to multiply our 2 moles of sodium chloride times our mass. So 2 times 58.4427 and we'll find that the number it gives us is 116.8854 grams of sodium chloride. Now, we've got 3 significant figures here, and we've got more than 3 in our mass number. So we're going to round this to 3 significant figures. So we're going to 1, 2, and this is the number we're going to round. So we have to look at the 8. It's above 5, so we're going to round this up to 117 grams of sodium chloride. Now what I want you to see here with the way we're setting these problems up is what is actually happening to the units. So in our very first example up here, 3 dozen times 12 roses gives us 36 roses. So our unit changes from dozen to roses. And the reason for that is because we're multiplying by the number of roses and then dividing by a dozen and then dividing by the dozen that it's in. So these cancel out and we're left with just roses as our unit. Same thing here. We've got dozen times roses over dozen, or 12 over 1, our conversion factor. So our dozen cancels out and we get roses. In our problem that's more chemistry based, we have 2 moles times grams over moles. So our moles are going to cancel out and we're going to be left with grams. And that's how we know we have 117 grams as the proper unit in this calculation. So we can go from moles to grams to find out how many grams we have of a substance, but typically I don't count a bunch of atoms and be like, I've got exactly 2 moles here. I typically would weigh something and then figure out how many moles I have. So we need to be able to go the other way as well. So I'm going to say we've got 92.387 grams of glucose. We solved the molar mass of glucose yesterday. So let me go back and look at our number. So for every 1 mole of glucose, we're going to have 180.156 grams. So notice this time our number and our conversion factor is on the bottom. If it was on the top and we multiplied these two, we would have grams squared per mole. That's weird. So instead we need to be able to divide by grams to cancel out our grams and end up with moles as our final answer. So 92.387 divided by 180.156 is going to give us 0.5128166. So we're going to have 0.51281. Oh, need more numbers than that. 666. 666 moles of C6H12O6. Now, this one I probably should have rounded yesterday, but I didn't. So we're going to take that as a true number, or as a measured number, but it's got 6 significant figures. This one has 5. So we're going to be rounding to the 5th significant figure because we're doing a multiplication division problem. So 1, 2, 3, 4, 5. So this is the spot we're going to round to. So our answer is going to be 0.5128, and then we look at the next number. The 6 is going to make that become a 2. Then we have 0.51282 moles of glucose.